Welcome to this rapid-fire explainer. Okay, today we're taking an incredibly massive, highly technical scoping review freshly published in the Samsara Journal, and we're boiling it down into the 3 most intriguing facts about the absolute cutting edge of cancer research. If you want to know how scientists are finally outsmarting one of the most notoriously stubborn cancer proteins on the planet, well, let's just dive right in. To really grasp the sheer scale of what we're talking about today, we got to start with this number, 74,272. That is the total number of patient and sample observations analyzed in this sweeping evidence map. The researchers didn't just, look at a handful of trials. They actually synthesized data from over 700 original studies. That gives us a definitive bird's-eye view of how RAS and KRAS cancer inhibitors are performing in the real world. It's just a colossal foundation of data, which perfectly sets up our very first mind-blowing fact.
So, fact number 1, the setup. For decades in oncology, the KRAS protein was basically known as the ultimate locked safe. See, it's a protein that, when mutated, acts like a stuck gas pedal, just driving rapid cancer growth. And for the longest time, it was deemed completely undruggable because its surface is incredibly smooth. There were virtually no pockets for a drug to bind to. It was a literal molecular fortress. But scientists have finally cracked it. They're using these new allele-specific inhibitors, which are essentially microscopic keys cut to fit only the mutant, cancerous versions of the protein.
And the implications of this? They're absolutely massive. As the paper explicitly states, RAS and KRAS inhibition in cancer is now, quote, therapeutically actionable. Now, in the medical world, those 2 words, therapeutically actionable, are incredibly exciting. It means these tumors are no longer an impenetrable death sentence. We finally have the tools to directly target and suppress these specific mutant-driven cancers. It's a colossal breakthrough in targeted therapy. But, well, there's always a but when it comes to biology, right? Because cancer doesn't just give up that easily.
And that brings us to fact number 2, the twist. Cancer is, unfortunately, a master escape artist. The researchers found that even when these amazing new drugs successfully lock the front door by inhibiting KRAS, the cancer simply finds an open window. In the scientific literature, they call this adaptive RAS MAPK reactivation. But really, you can just think of it as a microscopic, high-stakes game of whack-a-mole. You smash the KRAS mutation down, and the tumor rapidly rewires its internal circuitry to reactivate growth through completely different pathways. And this whack-a-mole game gets wild quickly. The data reveals that acquired resistance emerged in 46% of all patients. But here's the crazy part. The cancer's escape strategy varies drastically depending on the organ. Colorectal cancer adapts incredibly fast with a staggering 69% acquired resistance rate. Meanwhile, non-small cell lung cancer sits much lower at just 26%. So this tells us that cancer isn't just one single puzzle. Its escape strategies completely depend on the specific tissue it's living in.
Okay, so how do we actually win this game? Well, that's fact number 3. The future isn't about finding a single silver bullet. The old strategy of relying on direct inhibition alone, it just isn't enough anymore because of that adaptive escape we were just talking about. The future strategy, which is heavily supported by the Samsara data, is all about rational combinations. Basically, scientists are now designing coordinated systemic cocktail strikes. They aren't just hitting KRAS, they're simultaneously deploying inhibitors against partner pathways and cellular escape hatches like EGFR, SHP2, or MEK. They're locking the front door, all the windows, and the chimney at the exact same time so the cancer has absolutely nowhere to run. All of this leaves us with one final, super provocative question. Are we finally cornering cancer's master escape artist? I mean, we've cracked the undruggable safe, we've mapped exactly how the tumors are escaping, and right now we are actively building the multi-drug cocktails to trap them for good. This explainer really just scratched the surface of the incredible molecular blueprints researchers are drafting right now. To find out exactly how these intricate pathway drug cocktails are being designed and to explore this massive data set for yourself, I highly encourage you to go read the full scoping review in the Samsara Journal. It's a truly fascinating glimpse into the future of medicine. Keep learning, keep questioning, and I'll catch you in the next explainer.